90% of diesel turbo failures happen because drivers ignore this one simple habit. By the end of this video, you will know what it is and how to fix it before it costs you thousands. Your diesel engine has one part that works harder than everything else under the hood. It spins at up to 240,000 revolutions per minute. That is 4,000 full rotations every single second. The only thing standing between it and total failure is a layer of engine oil thinner than a strand of human hair. That component is your turbocharger. And according to Garrett, one of the world's largest turbo manufacturers, more than 90% of turbo failures are not from a defective part. They happen because of something the driver did or failed to do. Most American diesel owners treat the turbocharger like just another engine part. Change the oil occasionally, drive like normal, and hope for the best. Japanese diesel owners think about it completely differently. They understand what the turbo genuinely needs to survive, and they build specific habits into their routine that most owners never consider. The result speaks for itself. Turbos in Japanese diesel trucks regularly reach 400,000 to 500,000 kilometers without replacement. Here is precisely what they do and why it works. 3 things destroy a turbocharger before it's time: oil starvation at startup, oil coking from hot shutdowns, and carbon buildup inside the vanes of variable geometry turbos. Every habit in this method targets one of those 3. When you turn the key on a cold morning, your engine fires within seconds. At that exact moment, the turbo is already trying to spin, but the oil has been sitting in the pan all night. The passages leading to the turbo bearing are completely dry. It takes several seconds for oil pressure to build, and for that lubricating film to reach the bearing. During those first few seconds, the shaft is spinning with almost no protection. Metal is grinding against metal. This is called dry start damage. It does not wreck the turbo in a single start. Instead, it strips microscopic layers of material from the bearing surface every morning, month after month, year after year, until the clearances open wide enough that the shaft wobbles, the seals fail, and oil starts burning through the exhaust. The fix is simple. Turn your key to the on position and wait 2 to 3 seconds before cranking. Once running, idle for 60 to 90 seconds before pulling away. At idle, the turbo spins slowly while oil circulates and reaches the bearings. You are pre-lubricating the system before asking it to work. In cold weather, below 41 degrees Fahrenheit, extend that idle to 2 full minutes. Cold oil is thicker and flows slower through narrow passages. Pushing the turbo before oil has properly circulated is one of the most reliable ways to shorten its life. The second killer happens at the end of your drive. After any highway run or sustained load, turbine housing temperatures can exceed 1,900 degrees Fahrenheit. The moment you shut the engine off, the oil pump stops, the coolant pump stops, but the heat does not stop. It soaks backward from the turbine housing into the center section, where the bearing lives. The oil trapped there has no fresh supply to carry the heat away. At high enough temperatures, it carbonizes, hardening into an abrasive deposit that coats the bearing and blocks the oil passages. This is called oil coking, and it causes the same damage as running your engine critically low on oil. The fix is a 2-minute cool-down idle before shutdown after any hard run. During those 2 minutes, exhaust temperatures drop, fresh oil keeps circulating, and the heat moves out safely. After a short, slow trip around town, you do not need to bother. But after any sustained highway run, 2 minutes costs nothing and extends the turbo's life by years. The third killer targets modern diesel trucks and SUVs built in the last 15 years. Most use a variable geometry turbocharger, called a VGT. Instead of a fixed housing, a VGT has movable vanes that pivot to control how exhaust gas strikes the turbine wheel. At low RPM, they close to eliminate turbo lag. At high RPM, they open for full flow. It is an efficient system with one specific weakness. Those vanes operate inside a hot, soot-filled environment. When a diesel spends most of its time on short city trips, exhaust temperatures stay low, and combustion stays incomplete. Carbon deposits build up on the vane surfaces over time. The vanes start to stick. Eventually, they seize. Vanes frozen closed create dangerous exhaust back pressure. Vanes frozen open kill low-end torque. Either way, the turbo comes out. The solution is a highway clean every 2 to 3 weeks. Get the truck on an open road, bring it to full operating temperature, then accelerate firmly and hold between 2,500 and 3,000 RPM for 10 to 15 minutes. The elevated exhaust heat burns carbon off the vanes and works them through their full range of motion. Think of it as a regen cycle for the turbo. Also, keep your eager system in good shape. When the eager valve sticks or the cooler degrades, it pushes excess soot back through the intake directly into the turbo. A neglected eager system accelerates carbon buildup fast. If your eager valve has not been inspected in the last 50,000 miles, get it checked now. The one maintenance item that matters more than anything else is engine oil. The turbo bearing runs on a film of oil thinner than a human hair at 240,000 RPM. If that oil is old or the wrong grade, the film breaks down faster under heat. Degraded oil carries suspended carbon particles. At turbo speeds, those particles act like sandpaper, slowly widening the bearing clearances. Once those clearances open far enough, the shaft wobbles, the seals fail, and the turbo is finished. Use a full synthetic oil meeting your manufacturer's specification, and pay attention to the ASHA rating. For turbocharged diesels, that rating determines how well the oil resists soot thickening and high-temperature deposit formation. Do not follow the maximum service interval. Change your oil every 5,000 to 6,500 miles. Modern diesels often list intervals of 12 to 18,000 miles. Those figures are based on ideal conditions. And ignore short trips, cold starts, and towing. Short oil changes are cheap. Turbo replacements cost between $1,000 and $3,000 before labor. One final habit that costs nothing and gets ignored by almost every diesel owner. Check your air filter and intake hose. The turbo compressor wheel spins fast enough that a single grain of sand can chip a blade. A chipped blade unbalances the wheel instantly. An unbalanced wheel at these speeds destroys the bearing in minutes. Inspect the air filter every 9,000 miles and replace it every 18,000 miles. Sooner in dusty conditions. Each time you change the oil, check the intake hose between the filter housing and the turbo inlet. Look for cracks, splits, or loose clamps. A cracked hose bypasses the filter and sends grit straight into the turbo. These cracks are common on older trucks because the hose sits near hot engine components. They are cheap to fix. A destroyed turbo is not. 5 habits. Idle 60 to 90 seconds on cold starts. Cool down 2 minutes before shutdown after hard runs. Highway clean every few weeks to keep VGG vanes moving. Full synthetic oil every 5,000 to 6,500 miles. Air filter and intake hose inspected on schedule. The difference between a turbo that dies early and one that outlasts the truck is almost always maintenance discipline, not luck, not the brand on the tailgate. Build these habits now, and your turbo will handle everything else.